We're now going to discuss some of the more basic properties of logarithms. The first is that when we have a logarithm whose base and argument are the same, this is going to have an output that is positive 1. Now, this is because if we were to convert this over into exponential form, we would start with the base that is a, raise it to the power of 1, and that would bring me back to the argument itself. And we can see that, of course, a is equal to a, so that is why this property is true. If the base and the argument are the same, the output of that logarithm has to be 1 because a raised to the first power is a. Similarly, if we take a base a and raise it to the 0 power, that's going to bring us back to the argument that is 1 as well. And we can see that converting to exponential form by looking at a raised to the 0 power is 1, right? Start with the base, raise it to that power, and it brings us back to whatever the argument was. So any base with an argument of 1 is going to have an output of 0. If we think about this next one from the perspective of converting it to exponential form, we would start with base a, we would raise that to the power r, this r here is the exponent for exponential form, and that would bring us back to the argument, which in this case is a raised to the r power. So we can see in exponential form that these two are equal to each other, which means that then this logarithm must have been equal to r, right? If the base and the argument have the same quantity and that argument is raised to a power, then this logarithm has to have an output that is also r. This one is a little bit trickier to see, so we're just going to jump straight to that proof. And essentially what we're going to notice here as a pattern is that the base of this is actually exponential form, right? Because I have a base that is being raised to a power. Now, there is a logarithm in that power, true, but because we have a base raised to some power, we would say this is in exponential form. Now, so considering that from exponential form, considering that this is in exponential form, we could convert it to log form. If we convert it to log form, then we're going to start by writing down the word log, and we're going to say that the base from exponential form is going to be written as a subscript on the logarithm. What the exponential equation is equal to becomes the argument when we convert it over into log form, and a logarithm is always going to be equal to whatever that exponent was when we were in exponential form. Well, the exponent was log base a of r, so that's what this thing is going to be equal to, and here we can say this is definitely a true statement, so the exponential function or the exponential equation from which we got this statement must also be true. So these are some quick little explanations about some of the more basic logarithmic properties. Let's look at a few examples of how that plays out. So our first example, we have the log with a base of 1/4. Well, notice that the argument is equal to 1. Anytime the argument is 1, doesn't matter what the base is, the output of that logarithm has to be 0. And let's just look at it back from the exponential form. Let's convert it to exponential form to see that if I take the base and raise it to the 0 power, that has an output of 1. This is true, and therefore the output of the logarithm that we had a moment ago must also be true. Looking at this next example, we've got 5 raised to the power log base 5 of 2. And just a reminder, what we saw from that property a moment ago was that a raised to the log base a of r turned out to be r. Again, this is one that looks a little bit weird and something that I recommend you just memorize. So we have 5 to the log base 5 of 2. That's got to be 2. It's going to be, the output is going to match whatever that argument was in the logarithm. And again, we can say that if we were to convert this to log form, right, because we have a base raised to a power, it's currently in exponential form, even though that power contains a logarithm. Because it's a base that's raised to a power, it's an exponential form. Converting to log form, we get log, we got to write down the word log, the base is 5, right, because that's going to be the thing that's being raised to the power. The argument is 2 because that's what we are equal to from the exponential form, and log base 5 of 2 is going to be equal to whatever that exponent was when we were in exponential form. Well, that exponent was log base 5 of 2. So we can see that when we convert it to log form, we end up with a statement that's obviously true. So that means that the equation this came from must also be true. This is true because this is true. The last example we'll look at in this video is log base 3 of 3 raised to the 2 power. So we're looking here, again, a logarithm is going to have an output that is an exponent. So we're looking here to find who is the exponent that needs to go on 3 in order to bring us back to the argument, which is 3 squared. Well, that exponent would be 2 because 3 raised to the 2 power is equal to 3 raised to the 2 power. Again, we're kind of drawing a counterclockwise circle. We start with the base, we raise that to the exponent, which is 2, and that's supposed to bring us back to whatever is in the argument. And from the property perspective, we can say anytime the base of the logarithm is going to match the base of this argument, that means that the output would have to match the exponent piece.